Okay, so here we're going to look at coding. In essence, coding is where the original data has been modified and we want to find a statistic from the new modified data. We're going to refer to that modification as coding. If I knew the original mean, could I quickly find the new mean? If I knew the original standard deviation, would I be able to quickly find the new standard deviation? So that's what coding's about. Can we find those statistics quickly and easily if we know what the coding formula was? Here I have the box plots for two sets of data. One being the original data and one being the original data, but I've added 10 to each specific data item. Having a look at the box plots, they look congruent. They look exactly the same, except one of them has been shifted to the right. It's been shifted to the right by 10. I have some summary statistics along the bottom. Some of the values remain the same. Some of the values are going to change. The mean has increased by 10. The standard deviation is unchanged. The minimum value, the lower quartile, the median, the upper quartile, the maximum value, all of them have increased by 10. And hopefully that should make sense to you. There's no extra spread in the data since all of the values are still the same distance away from each other. They've all increased by 10. So the range that we used to have is still the same range. The interquartile range we used to have is still the same size. The coding formula here was y equals x plus 10. The measures of location, they were changed, but the measures of spread, they stayed exactly the same. So let's have a look at another example. This time round, I've multiplied each of the values by 3. And we can see on the box plot, this has quite a drastic effect to the range. It has a significant effect to the interquartile range. These measures of spread have become larger. Since each of the values has increased by 3, the gaps between each value have also increased, which makes these overall measures of spread larger as well. So, if we look again at these summary statistics, we can see the standard deviation has changed. It's increased by 3-fold. The interquartile range, the gap between the upper quartile and the lower quartile, has increased 3-fold. This time round, the coding formula was that y equaled 3x. And this time round, coding affected not just the measures of location, but also the measures of spread. Okay, let's see if we can generalize this now. In general, the statistics we're going to work with can be split into 3 different groups. Firstly, measures of location. So these are things like x bar. These are things like the mean, the median, the mode, the minimum, the maximum, the quartiles, the percentiles, the deciles. All of those are measures of location. And they will all be affected the same way by your coding formula. We also have measures of spread. So these are things like the interquartile range, the standard deviation, interpercentile ranges. All of those will once again be affected in the same way. And finally, we have a group which are all affected in the same way that the variance is affected. So the variance, the S of XX, S of YY, S of XY. Now, a lot of these will only come across in further maths, but we'll talk about how they're affected here together. Well, as we saw before, addition affected all of the measures of location. All of them were shifted up by 10 in the example that I used, but it had no effect whatsoever on the measures of spread. They all remained the same. Well, subtraction is going to work exactly the same way as addition, where it only affects those measures of location. No effect on the measures of spread. Now, when it came to multiplying, multiplication did have an effect on both the measures of location and on all those measures of spread. And once again, division, as you'd anticipate, works exactly the same way as multiplication. So, what I can say here to summarize is that the only thing to affect measures of spread is multiplication and division, whereas all operations, adding, subtracting, multiplying, and dividing, will affect the measures of location. So what this means is that when you're told a coding formula, you could rewrite it to specifically represent your measure of location or specifically represent your measure of spread. So y equals x plus 10, I can rewrite that as y bar equals x bar plus 10. But when it comes to the measure of spread, I can say sigma y equals sigma x. The adding has no effect on the standard deviation. Secondly, y equals 3x. As we discussed, multiplying affects both the measure of location and the measure of spread. It's going to affect the mean and it's going to affect the standard deviation. Y equals 2x minus 5. I'm going to get y bar equals 2x bar minus 5. But for the standard deviation, I'm going to ignore the adding and subtracting. So I get sigma y equals 2 sigma x. And here as well, the coefficient of x is a half, so we can see that as the division, and then we're adding on 8. So y equals a half x plus 8. Both of them are going to be applied to the x bar. Only the multiplying by a half is going to be applied to sigma. Okay, so now that we know how to rewrite a coding formula for the specific statistic we're working with, either for the x bar or for the sigma, we should be able to use that formula to either find the original mean and standard deviation or to find the coded mean and standard deviation, depending what we're given in the question. Okay, let's have a quick look at a few examples. So here I've been given the coding formula and the coded data. So a coded mean, which is y bar, and a coded standard deviation, which is sigma y. The first thing I want to do is to rewrite the formula specifically for x bar and specifically for sigma x. So we can think of this dividing as a coefficient of a half, so y equals half x, which means y bar will equal half x bar. Multiplying affects the mean. Sigma y is going to equal half sigma x because multiplying affects the standard deviation. Okay, so from there, I'm just going to substitute in the values that we have. So I've got y bar, which is 20. So 20 equals half of x bar. In that case, x bar must equal 40. Similarly for sigma, sigma y is 3 over 2. So I have 3 over 2 equals half sigma x. And from there, I know that sigma x must equal 3. This time around, two operations, the subtraction. So once again, specifically for the mean, so I can say that y bar equals 3x bar minus 20. Multiplication and subtraction affect the mean. However, it's only the multiplication we need to consider. Sigma equals 3. Okay, we've been asked to find the coded values, so we'll substitute 35 for x bar. That gives me 105 subtract 20. So y bar must equal 85. Okay, so similarly, we've been told that sigma x is 4. So sigma y is just going to be 3 times 4, which gives us 12. Sigma y equals 12. The coded standard deviation must equal 35. Okay, so we've got some fractions involved here. Y equals x plus 10 over 3. Rewrite that for x bar and y bar. So y bar equals x bar plus 10 over 3. Quite simple. For the standard deviation, we can ignore the addition of the 10. So sigma y equals sigma x over 3. Okay, let's substitute what we've been told. We've been told the original mean and standard deviation, and we're looking for the coded mean and standard deviation. So 11 plus 10 over 3, 21 over 3. Hope you can do that in your head. Gives us an answer of 7. For the standard deviation, x sigma bar is 27. 1/3 of 27, or 27 over 3, gives us 9. The coded standard deviation is 9. And we'll just do one more here where we're uncoding, where we're trying to find the original values. So y bar equals x bar minus 100 over 5. Sigma y is going to equal sigma x over 5, or 1/5 of sigma x. Okay, we have the coded values to substitute in. So y bar is 40, and we're going to rearrange to make x bar the subject. So multiplying by 5, adding on 100, that gives us x bar equals 300. Similarly, for the standard deviation, the coded standard deviation was 5. So 5 equals 1/5 of the original standard deviation. Should really be one step in our heads. The original standard deviation is 25. Okay, so each time you have a coding question, you want to rewrite the coding formula specifically for the statistic you're working with. So either in terms of x bar and y bar, or in terms of sigma x and sigma y. Once you've done that, it really is just substituting and rearranging an equation. Okay, and we're just about finished, but before you move on to some practice questions, let's take a quick look at the specification and exactly what it is that students are expected to be able to show, exactly what the examiners are anticipating you will be confident on. While you read through that, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date, maybe come back in 2 or 3 weeks or before an assessment. And as you watch through the second time round, because you've done your practice, a lot of what you go through here should resonate with you much more. And you have a chance to really embed your understanding of the difficult concepts, the ones that have been flagged up as A star.